I am Dominique.
And I am Randy.
And we are going to talk all about the domain
and range of functions.
Are you ready? Let's go. The domain is the set of all x values in a given function. That means all the numbers that you could possibly input in this function for x.
The range refers to the set of all y values in a given function. That means all the numbers that you could possibly obtain as outputs of this function.
Let's look at this graph.
It is only a bunch of points, but we can still identify its domain and range.
Remember how we said that the domain is represented by all the x values? Here, -5, -4, -3, -2, and -1 are all the x values that are part of this function. As you gather these numbers, it doesn't matter what order or sequence you list them. Just make sure you get them all.
Next, we can pick off all of the y coordinates defined by this function. These represent the elements of the range. Again, it doesn't matter which order you gather or write them in, as long as you don't forget any. Also, if any number appears more than once in the range, you only need to write it one time.
All we have to do now is write these numbers in a set of curly brackets, with each element separated by a comma.
And make sure you clearly label which is the domain and which is the range.
We've seen a lot of functions that are more than just points.
Most functions we will see will be curves.
Domain still refers to the set of all x values that the function reaches.
And range still refers to the set of all y values that the function reaches.
If you start by labeling some perfect integer coordinates, you are leaving out the majority of the function.
Like these ones.
And these ones.
And these ones.
Not to mention that this function extends to the right forever. So start by asking yourself, what is the smallest that x can be? You see that -5 is the smallest x coordinate at any point on this function. Then, you should ask yourself, what is the biggest that x can be? This function keeps going to the right. Forever, what number will it reach? Trick question, it won't. Infinity is the right-hand boundary of those x values. Say that the x values span between -5 and infinity.
The range works very similarly. Ask yourself, what is the smallest that y can be? The point -5, -3 is the lowest that this graph will ever reach. Therefore -3 is the smallest y coordinate on this entire graph. What is the largest that y can be? Not only does this function extend to the right forever, and even though it happens very slowly, it also extends up forever. That means that the upper boundary of the y coordinates here is infinity. We say that the y coordinates in this function span from -3 to infinity.
Domain and range are commonly expressed in interval notation.
Interval notation is like saying from here to there.
If you want to say that the domain spans from -5 to infinity, you have to use a square bracket next to -5, and a parenthesis next to infinity. The square bracket means that -5 is included in the domain. It is the same as saying x is greater than or equal to -5. You must use a parenthesis next to infinity. It is like saying x is less than infinity, but not equal to it. You can never technically equal infinity.
Again, the range works similarly. If you want to say that the range spans from -3 to infinity, you have to use a square bracket next to -3 and a parenthesis next to infinity.
Let's look at the domain and range of this parabola.
Again, you could plot some perfect little points, but these x and y coordinates only represent a small portion of the domain and range.
Also, this graph extends up forever. That means there must be a point at the coordinate -10, something. There must be a point at -100, something. There are also x-coordinates at -1000 and -1,000,000. In fact, this parabola, if extended on forever to the left, would be bound only by infinity. What about the right-hand boundary? You guessed it. The x-coordinates will make their way all the way up to infinity on the right as well. That means the domain includes all x values from -infinity to +infinity. This essentially means that x could be any real number.
How about the range? What is the smallest y-coordinate possible in this function? If you said -6, then you are correct. This graph has no way of extending below -6. How about the largest y can be? Is there some coordinate all the way up at something, 10? How about up at something, 100? Of course. This parabola will extend up forever, and the upper bound for its y-coordinates is infinity. This means that the range spans from -6 to infinity.
Don't forget about our interval notation, where a square bracket means that -6 is part of the range and the parentheses are because you can never really equal infinity.